Welcome to our podcast, where we cover unique and interesting stories for you. In this episode, we will discuss, did India's Deccan Traps wipe out the dinosaurs? The extinction of dinosaurs on Earth is said to be the most massive blow to life on the planet after it was hit by an asteroid. However, there have been many hints which suggest that asteroids may not have been the reason behind the mass extinction of the dinosaurs, but only the most spectacular isolated contribution. Before the dramatic event unfolded nearly 66 million years ago, toxic winds of change had started blowing in the air. In a new analysis carried out by an international team of researchers, new evidence has been added to the claims that before the asteroid explosion, the world was anything but a paradise, as the measures of sulfur reached critical levels in the atmosphere. Along with other studies on levels of mercury, the research has observed a signature of volcanic activity, which was strong enough to lead to significant climate disruptions. The timing of the volcanic activity was dismissed in 1991 as too early to be behind the mass extinction of dinosaurs. However, recent studies have demonstrated the possibility of the timing being close enough to be significant. Our data suggest that volcanic sulfur degassing from such activity could have caused repeated short-lived global drops in temperature, wrote University of Oslo geoscientist Sara Calegaro and colleagues in their paper. The rocks from the Deccan Traps, which is one of the largest volcanic features and is located in West India, were examined by the team. A new technique has been developed for measuring sulfur concentrations by applying them. As per the models, sustained sulfur emissions from the Deccan Traps were enough to alter the global climate substantially. A huge amount of 1 million cubic kilometers of molten rock was released only from this volcanic region. The formation of highly concentrated sulfur, which was filled with lava at Thakurvadi Tubushe in the region, has coincided with the cooling Cretaceous climate, observed the team. The basalt in the area is generally less in sulfur, which indicates that the cooling molecule was released from the hardened magma slowly into the atmosphere after eruptions. This is likely to have resulted in an increase in global temperatures in bouts of up to 10 degrees Celsius within 100,000 years before the Chicxulub meteor finally hit the Earth. Our research demonstrates that climatic conditions were almost certainly unstable, with repeated volcanic winters that could have lasted decades prior to the extinction of the dinosaurs, said McGill University geochemist Don Baker while speaking to Science Alert. This instability would have made life difficult for all plants and animals and set the stage for the dinosaur extinction event, he added. Thanks for tuning in. If you enjoyed this episode, be sure to subscribe and share your thoughts in the comments. Stay connected for more exciting discussions and updates in our next podcast.